Hi, I'm Sid, and in this video we're going to be covering some useful data structures for competitive programming. If you don't already know like the basics of programming languages, for loops, while loops, and basic data types, then I would suggest watching my Introduction to Competitive Programming video, which I'll link in the description. Other than that, let's get right to it. The first data structure that I'm going to be covering is the vector, which is a dynamic array. And if you've used Java, then you'll be familiar with this. It's very similar to a array list. Now, to get started, hashtag include vector. In my previous video, I had just done hashtag include bis/standard c++.h, and that included IOStream and vector in its import, so that's not needed anymore. I just showed you guys that to show you where the vector was coming from. Like an array list in Java, to initialize a vector, each vector can only have things of one data type. So you have to pass that in as an argument when you're creating the vector, and then obviously give it a name. Let's call this inputs, assuming you're taking in inputs for a competitive programming contest. To add a element to a vector, you can do, suppose this is when you have no elements in the vector. This initializes the vector and it gives the first element a value of 1, and every time you use pushback after this, it'll add it on to the end of the vector. So if this 1 is at index 0, 2 will be at index 1, and then if you added the next element would be at index 3, 4, and so on and so forth. Like normal arrays in C++, you can access the elements of a vector using the square brackets, like so. Suppose we want to get 2, the index of 2 is 1, so we would just do that. And that will give us our answer, which is, hopefully, is 2. See? Voila, 2. So this is how you just index into vectors, very similar to normal arrays, clearly so far. Another useful thing with dealing with any of these data structures from the standard template library, which is where all these data structures are from, is knowing how to use iterators. The data type of an iterator is where T is the data type you're using, data structure you're using. So for a vector that contains integers, this would be, the type of the iterator would be vector int : iterator. Now clearly you wouldn't want to type this out every time, so starting with C++11, there's a very helpful keyword called auto that automatically assigns the data type for you. I wouldn't suggest using this for anything other than iterators because it can produce some unwanted effects. But let's get introduced to our first iterator. Auto it equals inputs.begin. Print this out. To print out an iterator, or to use it in any other form than in a than the iterator data type, put an asterisk behind it, and then you can use it as intended. So let's compile again and see what this outputs. And apparently I forgot to do anything at all. So, I didn't save the file, so it didn't update the compilation. And here you'll see it print out, and it prints out 1, which is expected because inputs.begin clearly goes to the beginning of the vector, and the element at the beginning of the vector is 1. Iterators are useful for a lot of things. You can use iterators to find elements in a vector. You can use iterators to get the beginning and the end. So you can use them to loop through a vector, as the name suggests. Iterators, you can use them to iterate through things. Iterators are very powerful, and you should keep them in mind as we move towards some other data structures. Now let's look at queues. Queues, like vectors, to initialize them, you name the queue, give it a name, it can be basic, and add Q. And Qs are included in, as I included, bits standard C++.h, so the standard template library, so you don't need to worry about that. You don't need to include anything else. Qs work just like lines in real life do. There's the front of the line, there's the back of the line, and Qs will always return the element at the front of the line. So when you push something, you're adding it to the back of the queue or the back of the line. So this 10 is being added to the back of the line. If you want to see what's at the front of the line, we do q.front. It returns what's at the front of the line. And to see this, let's do g++ q.cpp to compile. And done ./a.out. And I didn't save it, so that would output nothing. Whoops. Now that we've seen that how to get out the front of the queue, to see the element at the front of the queue, there are a couple of other methods that are helpful for a queue. You need to know how to pop a queue, and pop will get rid of the element in the front. Q.size will return the number of elements. So after this, q.size will return 0 because we've popped the front element and there's only one element, so now there are no elements left. And then q.empty will return a boolean that determines, and this is true if and only if there are no elements in the queue. In this case, there are no elements in the queue, so it will return as such. Stacks are very similar to queues, and remember, we don't need these, we can just do. Also, you should only be doing this for competitive programming, as doing it for like a software development project it's just bad practice. But that doesn't matter for competitive programming. Competitive programming is meant to be quick and efficient. So continuing on, we have, so stacks are very similar to queues. Initialize them in the same way, except there's one minor difference. Instead of a queue being from back to front, a stack is bottom to top, and pushing onto a stack will actually add something to the top of the stack. So whereas in a queue, and to return the top of the stack, you do .top. In a queue, if this was s.front, it would have returned 10. But because we're using a stack, I don't know why that's happening. Oh, it's because I called it g++ stacks.cpp. So always make sure to know what your files are named, unlike me. And when you compile and run this, you'll get 20, which is expected because we put 10 at the bottom of the stack, and then we put 10 at the top of the stack, and then we put 20 on top of the stack again. So 20 is now at the top of the stack. And similarly to a queue, when you pop something, it'll remove it from the top of the stack. Now let's cover something, and then the other methods that a queue has also exist. You have empty, which checks whether it's empty or not, and you also have size, which is great. And these do the same things that they do in a queue. Now, the next data structures that I have is the priority queue. The priority queue is also a member of the standard template library, just like every other data structure in this video. And to initialize it, you do it much the same way that you would any other of these, a stack or a map or a queue or a vector. You define it by giving it the data type that it holds. So in this case, we're initializing a priority queue PQ that contains integers. Now, Priority queues are similar to queues or stacks, but instead of the frontmost or topmost element being returned when you use .front or .top, you have the greatest element always returned. So the greatest element is always at the front of the queue, the priority queue. And to get some other way of sorting the priority queue, then descending, you can use a comparison function. So syntax for this looks something like bool return A is less than B. That's interesting, but we'll see what happens when I compile. Now, what this does is it creates a priority queue that of an integer has a vector of integers from a vector of integers using the comparison function. So in this case, what's happening is when we're adding elements to the priority queue, they're being added in ascending order instead of descending order, which is helpful to have because most of the time, having the greatest element always returned by default is great, but sometimes you'll want to have some custom ordering of elements in the thing. Then the other methods for the priority queue are the same as the stack and queue. You have push, pop, top, empty, and size. The basic functions that you need. So the next data structure that I'm going to cover is the set, which is really versatile and super cool. So a set's basically akin to the normal mathematical set, which is a collection of unique elements. It's included in the set, and we can get rid of that and just use our favorite include statement using namespace standard. Now, to declare a set, to initialize a set, it's basically the same thing. Set ints, a set of integers s. The interesting about set, and then to add an element to set, you're going to do insert 4, 7, or 1, or whatever elements you have. And the way sets are ordered in ascending order. So you always have the least element, so you have the minimum element of the set at the beginning, and you have the largest element at the end. So when we insert 4 here, 4 is just placed as the only element of the set. When we insert 7, 7 is inserted after 4. And when we insert 1, 1 is inserted before 4. So the set would look like 1, 4, 7. Now sets, unlike vectors, don't allow you to access elements like this. This is a illegal thing, as our text editor is kindly telling us here. So the only way to actually access elements with a set is using iterators, like I mentioned before, with vectors. So let's comment all of this out. We'll get to that in a bit. But what I'm doing here is we have an iterator that finds where 4 is in the set, and then we output 4. To get to the next element, you would do it plus plus, and this increases the iterator by 1, and now this should return, let me save that first, this code should return 7. Let's see if it does. Compile, compile, compile. And it does return 7. That's great. So iterators are a very powerful thing. Now the set has other methods. We can use .erase, and this will erase, as you could tell, 7 from the set. Now once we do this, if we wanted to see if 7 doesn't exist in the set, we say if s.find7 equals s.end. Now end is 1 after the last element in the set, so s.find7, if s.find7 is 1 after the last element in the set, that means it doesn't exist, and this will output 7 is not in the set. Let's see if this actually does happen. Save, compile. As you're writing code, it's always a good thing to compile often. And as predicted, because we erased 7, 7 is no longer in the set. To just find the smallest element of a set, you can do you just have to find the beginning element of the set. So this will return 1, and we can check that really quickly by compiling and running. The smallest element of the set is 1, as expected. Now moving on to the last data structure that I'm going to be covering in this video, we have maps. Now maps, if you're familiar with Python or Java, they're like hash maps in Java and dictionaries in Python. They're very similar to sets, except they're each in a map there's a key and a value. So again, we can just do hash include using namespace standard int main, and with this map, what I'm trying to do is we're going to map a key of data type string to a value of data type integer, and this is how you would initialize a map. So we're going to call this age, and I'm going to store ages based on people, the ages of different people. So I'm Sid, my age is 17 years old, so we're going to have the string. We're going to initialize the key Sid with a value of 17, and then we're going to initialize the value Bob, and the key Bob with a value of 18. If age.find Joe equals age.end, there should be no record of Joe's age. And let's see if that's true. Again, this is pretty similar to what we saw in the set. If it's equal to the n iterator, the iterator for the thing you're trying to find, then it doesn't exist. And I should say no record of Joe's age. And then our next line just accesses the value for the key by indexing into the map like so. You can index into a map with the key instead of the value, and that will return the value. That's all for this video. The code for this video was, some of the code for this video was taken from the book Principles of Algorithmic Problem Solving. Forgot the author's name, but I'll link it down in the description. If you want to see more of these types of videos, like, subscribe, and follow me on Instagram. See you next time.